A binary number is a number written in base 2. When we count numbers in base 2, all these numbers make up the binary system. So you can simply say that a binary system are a set of numbers that are counted in base 2. Binary numbers are recognized by the presence of two major digits, the 0 and 1. So meaning that in binary numbers, you have just 0 and 1 as the digits. Examples of binary numbers are 1000111. We also have another example as 1100111001. On the other hand, we can say a denary or a decimal number is a number that is counted in base 10, or a number that has its base as base 10. Our natural counting system here in Nigeria is based on base 10 counting system. So every base 10 counting number has digits from 0 to 9. They have digits from 0 to 9. Examples of denary numbers are all the natural counting numbers. Here we have 898654 7600123. Let's take a look at this very example. It says, express the binary number 1011 as a denary number. So the first thing you are going to do here is to express the given binary number in the powers of 10. You express the given binary numbers in the powers of 10, starting from the very smallest power. So since we have 4 digits, it means that the smallest power is 0 and the highest power is 3. So we have 1 to the power of 3, 0 to the power of 2, 1 to the power of 1, then 1 to the power of 0. So by expanding this, we have 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. Now 2 to the power of 3 will give us 8. So we have 1 times 8. 2 to the power of 2 will give us 4. So we have 0 times 4. 2 to the power of 1 will give us 2. So we have 1 times 2. Then 2 to the power of 0 will give us 1. So we have 1 times 1. Now 1 times 8 is 8. 0 times 4 is 0. 1 times 2 is 2. 1 times 1 is 1. So we're going to sum everything up together. And when we do that, we have 11. So this simply means that 1011 base 2 is equal to 11 base 10 is equal to 11 base 10. Now, this is another example. It says express denary number 15 as a binary number. So in this case, we're expected to convert from base 10 to base 2. So the main principle here is division principle, where you keep on dividing by the base and keeping the remainder. So as you can see, we have 15 is equal to 15 divided by 2, which is equal to 7 remainder 1. We are also going to divide this 7 by the base 2 and keep the remainder. So here we have 7 divided by 2, which is equal to 3 remainder 1. Then we are also going to divide this 3 by the same 2 and keep the remainder. So in this case, we have 3 divided by 2, which is equals to 1, remainder 1. Then finally, we are going to divide the 1 by this same 2 and keep the remainder. But 1 divided by 2 cannot, so you keep it as 0 and keep the remainder 1. Then at this point, you read the digits from bottom to top so that you get your final answer. So when you read the digit from bottom to top, you have 15 base 10 is equal to 1111 base 2. Let's take this example. It reads, find the sum of the binary numbers 1101 and 1111. Now let's take the solution. Now before we start, you need to note that 1 plus 1 in base 2 is equal to 10. 1 plus 1 in base 2 is equal to 10. So here we have 1101 plus 1111. So the first thing you need to do is to add the numbers starting from the very last digits. So we have 1 plus 1, which is equals to 10. So we put down 0 and carry 1. This time around, we have 1 plus 0 plus 1, which will also give us 10. So we put down 0 and carry 1. Now, we have 1 plus 1 plus 1, which will give us 1, 1. So we put down 1 and carry 1. So finally, we have 1 plus 1 plus 1. That will also give us 1, 1. So we put down 1 and put down the remaining 1 in front. So now we have 11100 base 2. Let's take this example. It says, subtract 1011 from 1110. Both numbers are in base 2. Now let's take the solution. Now remember, when subtracting in base 2, any one you borrow is equal to 2. Any one you borrowed is equal to 2. So in this example, we have 1110 minus 1011. So here we'll start the subtraction from the last digit. So 0 minus 1 is not possible. So you have to borrow the 1 in front of the 0. So that one you borrow will be called 2. So we now have 2 minus 1, which will give us 1. So after borrowing, we are left with 0 there. So 0 minus 1 is still not possible. So we borrow the 1 in front and we also call it 2. So this time around, we have 2 minus 1, which will give us 1. So after borrowing that 1, we are left with 0. So now we have 0 minus 0, and that will give us 0. Then finally, we have 1 minus 1, which will give us 0. So we can do without the 2 zeros. So our final answer is 11 base 2. Let's take this example. In this example, it says multiply in base 2, 111 and 11. Now let's take the solution. Multiplication in binary is just like your normal multiplication, but bearing in mind the rules for addition and subtraction of binary numbers. So here we have 111 times 11. So we're going to multiply just like we do for ordinary multiplication. So 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So we multiply by the second digit. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So the next step is to add up the digits we have obtained. So we start from the very last digit. So 1 plus 0 is 1, 1 plus 1 is 10. So we put down 0, carry 1. So 1 plus 1 is 10 plus the one we carry 11. So we put down 1, carry 1. So 1 plus 1 is 10. So put down 0 and put the remaining 1 in front. So as you can see, our final answer is 10101 base 2. Thank you for watching this video. Join me in the next one.